First of all, good morning, everybody. I'd like to actually thank Osmine for the opportunity to present on Orica's latest blasting technology, 4D. During this presentation, I'm going to touch on 4D in the context of the broader mining value chain. I'm also going to talk about 4D in the context of Orica's broader digital platforms. I'm also look at the fundamentals of the technology itself, and lastly, and most importantly, how that technology translates into benefit and value for the mining industry and our customers. So we're proud to be playing a role in the future of mining by introducing, amongst other offerings, advancements in explosives technology to optimise the whole mining value chain. Orica this year turned 150, so we've been around for a long time. We've spent that time trying to perfect the process of blasting, and we understand the immense value that this stage holds in the value chain itself in the mining industry. The success or failure of the blasting process has a significant impact on the overall value created or lost in an operation. Despite advancements in other areas of the value chain, blasting has remained relatively unchanged for a long time. This lack of change actually results in poorly controlled blast outcomes and can have massive impacts on up to 80% of the total mine processing costs. So it holds a very important space in this whole chain. Given the critical role of transforming the rock's composition during blasting, Orica is well positioned to enhance end-to-end efficiencies in the mining process. 4D technology itself particularly influences how we approach blast design and the loading of explosives, as well as improving subsequent load, haul and processing activities. We'll talk about some of these benefits a little bit later in the presentation itself. So as the industry moves towards full integration, Orica is really proud to lead the change in digital automated blasting with 4D at the core. So if you look at upstream, we use Rhino to help our customers better understand their ore bodies to drive more informed decisions on what we do downstream. We then integrate complex geotechnical model information into our Shot Plus blast design software to optimise those blast outcomes. And once we've done this, we leverage our Blast IQ digital platform, and we use that to transfer data and information in real time to make changes into our mobile mixing unit so we can then deliver the blast the optimum way. 4D is the bulk system that is the tool for doing this, and this is where explosive energy is matched to the ground conditions for cost-effective and optimised blasting. Then we look at downstream, and downstream is where we focus on post-blast measurement and monitoring, and that's where we use our frag track system. We can use this to actually understand the outcomes of the blast, and from an iterative perspective, we can then use that information to feed back into the Rhino system to understand the ore body more, tweak our blasting, and further optimise those blast outcomes. So I just want to spend a little bit of time talking about 4D from an energy perspective. So this isn't about using more explosives or anything like that. This is around using explosives smarter. So selection of explosives and their application is usually driven by the ground conditions you encounter. The mining environment changes quite frequently, and as a result of that, the need for different explosives is required on a day-to-day basis. The energy range of traditional explosives, which is the dark blue area there, is relatively limited. So with the development of 4D, we now actually significantly expand that energy range by up to 23% for hard rock applications, and we reduce energy by about 43% for soft ground applications. This can all be achieved with a single bulk explosives, which hasn't typically been available in the past, without the need for multiple formulations and more costly raw materials. As a result of this extended energy range, it's now possible to more accurately match the explosives energy to the ground conditions you're encountering, irrespective of whether you're in hard rock, soft rock, you're loading into wet holes, dry holes, or something in between. So this is something which is a bit of a step change to what we've seen previously. We've been working on this technology for about 2 years, 3 years in a commercial sense, but there's been a lot more work from a research and development perspective prior to this. The one advantage of this is, I suppose, the explosives delivery fleet's quite expensive. So in terms of introducing this technology to a mine site, There's some small modifications required to the vehicles that we use to deliver explosives, but it's quite minor. So blast design has traditionally been driven by the densities of explosives, as we've mentioned before. The problem with these is they're limited in terms of their range, but traditional explosives are also influenced by hydrostatic pressure. What that means is we create an uneven energy profile within a blast hole, and again, this leads to suboptimal outcome from a blast perspective. With the introduction of 4D, we actually approach blast design from an energy perspective. So what energy is required to blast the ground? And once we, it's gone ahead. But once we understand what that's required, we then can put multiple energies between blast holes in that blast itself and come up with the right outcome. Most importantly, what's in it for the customer? So if we're looking at low energy applications, we can now reduce overblasting and eliminate the generation of fume or excess vibration. A lot of mines have very strict consent conditions, and this is one of those elements that 4D can assist those operations with. We can also reduce explosives consumption when blasting in soft, wet ground. Again, this saves the customer money, it saves time and efficiencies in loading. It also helps reduce our carbon footprint by reducing the consumption of explosives themselves. When we're looking at higher energy applications, we can now look to expand patterns to reduce drill and blast costs in production and waste, and we can release drill capacity to actually break more rock, release more ore, and make the operation more efficient. We can use this energy and the consistency in the energy to improve the fragmentation, reduce cap rock, improve the efficiency of the load and haul fleet, but most importantly, improve the efficiency of the milling process, which is where a lot of the costs are. Just realised I've run out of time. I had about 5 seconds left, but I'll leave it there for the purposes of the time. And if anyone's got any questions, please come and see me at lunch. I'll be around. I'm happy to share some more information. Thank you.